Okay, I guess we will see today if our bitrate gets messed up or not, but I wanted to make sure I got some Unity learning time in. So here we are again. Did I download those files already? I want to make sure I do that if I did not. Okay, I don't believe I did. Junior Programmer, starter files. Okay, we got that together. Anyway, we're looking at the version control stuff. What is version control? Version control, which is sometimes... I did turn my mic on, right? Yeah, I did turn it on. Mic is on. VTuber thing is moving. I have the right thing up. We're fine. Version control, which is sometimes called source control, is a system that manages and tracks information. Version control systems can be configured to store, manage, and track changes to any kinds of files, software, websites, or other data. Individual small teams or large organizations will often use a version control system to help back up and manage complex projects. Since version control systems work with cloud storage services, you can take advantage of useful features such as backup storage, version tracking, project management. In this tutorial, you'll learn about version control systems, which use cloud storage as opposed to those that use localized storage. Okay. Who uses version control? When multiple team members are involved with developing coordinated projects or software, it can be difficult to manage without a version control system in place. Everyone needs it. As a project becomes more complex, team members need to stay up to date with changes their fellow teammates make. If they don't coordinate consistently, they will face inefficiencies, bottlenecks, lost code, rework, and a lot of frustration. The purpose of version control is to avoid these issues. Okay? Select your version control tool. Yeah, Version control systems vary depending on your project needs. Unity has its own version control solution called Collaborate, which is available as a package. However, for this learning project, we'll be using GitHub, an extremely popular version control solution that you're likely to encounter during your development career. It's also easy to work with, especially for beginners with version control. To make things even simpler, we'll guide you to use GitHub Desktop, an easy-to-use application that allows you to access GitHub projects through a graphical user interface, instead of from a command line using Git commands. If you are already familiar with GitHub, or prefer to work with the command line, feel free to skip this step. The next step. If you're interested in reading more about how Unity integrates with other version control systems, please refer to our tutorials on Introduction to Unity, Collaborate, and working with Unity Helix Core Perforce. So I see no reason not to use this. And if you don't already have one, sign up for free at GitHub and get an account. I've used GitHub a lot, not gonna lie. I've used it a lot for different things. I see a lot of people use this stuff. Says we can do it for free, so might as well sign up for a free one. Enter your email. Let me just sign up for this without that there. Okay, we'll do... Like to receive product updates. No. Verify your account. Please solve this puzzle to verify that you are a human. Click Start Puzzle to continue. Pick the Spiral Galaxy. Pick the Spiral Galaxy. It's in the same spot. Create account. Okay, they sent me a verification code thing, so I'm just gonna grab that quick. I figure I probably shouldn't go flashing my email junk, even if people already know it anyways, because I'm pretty sure I've shown it plenty of times on here. Ugh. How many team members will be working with you? Office guide and use the tools that are best suited for your projects. I mean, realistically, student. Does this say anything? No. Select all that apply. So we can point you to the right GitHub plan. Oh, I feel like I'm gonna sneeze. I'll just say collaborative coding for now. I'll just use the private stuff for now. This is the GitHub I know. Okay, so now we got this stuff. So what are we doing? Download and install GitHub desktop at the desktop.com. Okay. Guess I'll grab it. It seems like it'd probably be useful. I've used GitHub a bunch, like I said. So, if it just helps me get that stuff together, might as well. I'll look at that later. Sign your desktop. It sounds like this would help a lot with keeping your code in proper place, though. Yawn. GitHub desktop. I'm guessing this just helps it connect with utilities that you're using, like Unity and stuff. Beyond having the GUI interface. Use my GitHub account name and email. Sure. Okay. So I think I have that all good. Sign into your account. On Windows, select File Options, Account. Okay, I mean, I guess I have that all. Create a new repo on your hard drive. Repository usually shortened to repo is a folder that a project lives in inside this folder. And all changes are carefully tracked by your version control software. First thing to do is create an empty repo that is configured specifically for Unity project. From the welcome screen in GitHub, select create a new repository on your hard drive. Junior programmer project. Or Unity learning. Select the pull path where you'd like to save. Folder name you just entered will be created there. Okay, we'll just save it with our create with code folder. So we've been saving everything else over there. Ignore drop select Unity option. This will create a pre-configured get ignore file in your repo that lists all of the file types that you do not want to store in version control. For Unity, that means it will only focus on the file specific to your project and ignore everything else. Okay. Create repository. This will select the current repository dropdown. Main menu, you'll see that there are currently no local changes. Oh, they just mean that there's 0 in there. Okay. Well, it says no local changes, like in here. Open the folder that was just created on your computer at the location you specified. Your computer is configured to view hidden files. You'll see contains 3 items. Yeah, I see the hidden files. Tells GitHub that this is in fact GitHub repo. Nor. Okay, you can Google how to do. Okay. Download, open, and start tracking your project. With your empty repo, patiently waiting changes to track, let's add a Unity project to it and open it for the first time. Extract it and open the repo started folder. In it, you find the following folders. So they want me to put those folders into this one? Okay, well I see all the changes now. My thing froze. Let's see. guess I can do it for this right now. More or less what I'm looking at. Just to show that. Okay, we got that up. Add your project repo folder, Unity Hub, then open the project in the Unity editor. Oh. Didn't look like it worked. This is another old version. Actually, everything's been using that. I don't think I've used any of the newer ones. Or is that slightly odor? No, I think it's fine. Maybe. It might not be fine. Well, I guess hopefully it opens normally. It even says to install the correct version thing. Your GitHub desktop window, a long list of new files now appears in the changes panel. Little green plus indicating it's new. Congratulations, your project is now ready. For version control, any changes you make to this project will be tracked by GitHub. So would this just help you figure out like what you've done? And like, can you make comments on it? Like, do you go like, I shouldn't have changed this. I need to go back and see what I changed that made it not work. And then you can see that easily there or something. I don't know. Probably a few ways to do that. Probably got a funny video. Huh. Understandable. A lot of people have been making fun of that that Turning Red movie with their, girl making smutty fanfics or whatever. A lot of people do it. I get paid for it. Live your dreams, girl. Boot 'em. This takes forever to load. The longest part of Unity learning. Waiting for the thing to actually load. Well, I know what it means to have that change. Do an initial commit and publish your repo. Commit to main. The first set of files you commit to your repo will be included in the initial commit. You would usually do an initial commit after you first set up your project, so let's do that now. In the summary field below the changes listed to your repo, type initial commit and fill the description, project starter files. Then select commit to main to save your changes to the main branch of the project. If you don't know what branches are, don't worry, we'll cover that in a later tutorial. After you click commit, all of the changes listed should disappear since they are now safely stowed away in the version control. However, even though all of your changes will be tracked locally on your hard drive, what if you accidentally drop your computer off a cliff? All your work would be lost. Let's back up your project on the cloud just in case. From the GitHub desktop interface, select Publish Repository. Okay. All my Unity stuff loaded. Okay. Little teeny scene. Got all little teeny stuff. We got this stuff. So, first starter. Commit to main. I'm trying to commit to main at least. Oh, that's how. Okay, they need a name for it and then a comment under it. Okay. Let's see. Okay, so that's all good now. We got all that stuff, and now we want to publish it. So how do they want us to publish it? And they don't have anything special for it. Okay, publish it. To see your repo backup, published on GitHub. Go to the top of the menu, the desktop, select try view on GitHub. Here you can explore all the files, view the commit history, log issues, and a lot more. Feel free to explore the interface and a bit more comfortable. Okay. View on GitHub. And here it is. Yeah, this looks like the stuff I would see when people are giving away different files. Interesting. Okay. How does version control work? Pushing and pulling changes. When you use version control, you'll save your changes to the project via cloud repository or file storage directory, with a note documenting the changes that you've made. This means that you'll be able to pull, download, and open the most recent version of a project, make changes to it locally, and then push upload your changes back to the cloud repository, merging changes. When multiple people are working on the same project simultaneously, they can sometimes make different changes to the same file. For example, one person might change the texture assigned to a prop asset in Unity project, and another might change its position in the scene. Version control manages the project files to combine and unify all changes in a process known as merge. Occasionally, the changes made to a project file may affect the same values. When this happens, the version control system is unable to merge the changes together, resulting in a merge conflict, which requires a developer's input. The version control system will identify the conflict, typically displaying the two different values side by side. The developer then determines which one to keep in order to resolve the conflict. One of the major benefits of version control is keeping track of all the changes over time, and if any changes are in conflict, or you decide it's best to revert to an earlier version, you can go back to any previous version of your project at any point and restore it. Okay, that sounds nice. Yeah, we learned the basics of that stuff. And now we can move on. Explore the sample project. Explore it, Snake. Explore it. Oh. Summary. In this tutorial, you'll take some time to review the project and explore Unity project for the application you're going to work on. You'll also consider the resources that are available to support before you begin. Project Brief PDF. Are they going to be a bit more hands-off in this one or something? I don't know if I'll need to download that, but we'll look at that in a second. Now that you've set up version control, you're ready to explore the main project that you'll use to both practice programming and connect the principles of object-oriented programming, OOP, with your own code. Let's get started. Okay. Before you continue, open the version of the project that you created in the previous tutorial. Check that you have Unity 20.3 installed. If it's not installed, a warning notification will be displayed for below. It's listing Unity prompt install correct version. Okay. I guess it's all fine, I think. Welcome to the project. Look at this. Got a whole little screen right here. A whole little thing right there. Okay. The Unity project you'll be working on is a resource management simulation application. Resource management is at the heart of a popular genre of games, but these simulations are also commonly used in educational contexts. For example, to explore sustainability in economics and in industry. This type of project is particularly good fit to help you explore programming systems and architecture, as they often include user interaction to enable them to influence the simulation, transitions between scenes to enable further customization by the user. Gonna refill my water. Systems designed for extension to increase the complexity of the simulation. And that is what that says. And now I'm still filling water. That's good enough. Quick. Explore the simulation. We have provided a basic resource management simulation in this project. Let's take a moment to explore it. In the project window, go to Assets, Scenes, and open the main scene. Select Play to enter play mode and review the simulation. At the moment, you'll find two different types of resource pile. Object on pallet, which both produce items at the speed of 0.5 per second. 3 transporter units, forklifts, which transport resources to the defined base, the space front of the truck marked with a red circle. Left-click any transporter unit or pile to bring user interface information with its details. You can use WSD key to move the word. Okay. Left-click a transporter unit. A green area icon will appear above it to indicate you have selected. Right-click one of the two resource piles. Transport unit will begin moving towards it. Experiment with what you can do. Transport unit, try sending one to a different place. Warehouse or changing its associated resource pile when active. Play again to exit. Okay. Well, we'll just we'll look this over real quick. Okay, let's see. Okay, so they're feeding. Huh. So this is more or less an RTS. Huh. Interesting. Sorry, can I always move these just as long as I hit that? I can go off the screen. That's not that big of a deal. Well, that's interesting. It's just neat to see that these kinds of games can be made very easily. And I could steal all the scripting from this to make it my own if I wanted to. Excuse me. Review the project brief. Now that you've reviewed the basic functionality of the simulation, it's time to go deeper. We've created a project brief, which will guide you through the contents of this Unity project, the basic functionality of the simulation, the additional functionality you'll implement over the next 2 missions in this pathway. Take some focused time to go through the brief. Download and save the brief. Review the document with the project open in the Unity editor so you can refer to the project as you do so. Fine, I'll save it. I'll just save it in there. Okay. Now I can go in here and open it. Review it. You might find it useful to open the script files and explore them in more detail. How much do you know about what they do based on your previous work in this pathway? I mean, I guess if you think about the logic, it's usually not that hard to figure out what some stuff's supposed to do. Launch application, menu screen, main scene. Main scene goes into menu screen, you can exit application. It's always weird how some people tidy this stuff up so much. We just go scummy with it. Okay, let's see. Let's see your goal in this mission. In this mission, you'll focus on getting the application functionality working. You'll implement the necessary scene flow and the user interface buttons, data persistence between scenes so the user can choose a color in the starting menu and apply it to the transporter units in the simulation. Data persistence between sessions so the last color a user chooses is pre-selected when they launch the application again. For your final submission, you'll apply your learning and implement data persistence in a simple game project. In the next mission, you'll then focus on object-oriented programming principles as you refine code and add new functionality to the simulation. Customize your application. Want to customize as you go? Please do. Although the focus of this mission is programming systems and architect, you'll find opportunities here to customize the project and consolidate your skills you learned in previous missions. We'll highlight some clear opportunities for you, but take initiative and be bold. No. What do you mean no? No, I won't. I don't wanna. So far, these things seem straightforward, but they're probably going to tell me to use the junk more. But real quick, let us look at the scripts here. Animator handler, color picker, search database, resource item. Then we got content entry, info pop-up, UI main scene. We got base, we got building, we got menu UI, handler, resource file, transporter unit, and user control. We don't even have a game manager in here. Game manager, not game manager. Anyway. We are now in Principles of Object-Oriented Programming. So we have, as you gain more practice with programming, you'll eventually begin to identify situations where you suspect code could be written more effectively. Perhaps you found yourself copying and pasting lines of code, or changing protection levels on variables multiple times as you add more to a project, regardless of the specific situation. These observations are an important part of becoming a better programmer. You're thinking beyond pure code functionality and considering your code's usability. There are many ways to improve the usability of code, and even many different options about the best approach. This can be overwhelming for new programmers. The best way to gain experience is to try these approaches yourself to help you get started. We'll show you one of the most popular programming paradigms or patterns, object-oriented programming. Object-oriented programming, OOP, is a programming pattern in which the method and variables are related to one another, are grouped together, to form what's called an object, the object in OOP. Public class rabbit, object. Years, floppy, standing, variables, color for color, void hop method. Keeping data organized into objects has many advantages. It makes code more comprehensible so that it is easier to understand what the code is trying to accomplish. In the example below, we can see that our rabbit object has a few variables to describe its physical appearance and a method that defines how it can move. It would be confusing if you opened up a separate class named burrow and discover a set of rabbit-related methods for eating carrots and nose wiggling. Would it? Object also allow you to control your code's accessibility, which means that you'll reduce the chance of someone else, or even yourself, accidentally breaking your code as you create your projects. You'll also be able to more easily reuse and repurpose different parts of your code. Keep in mind that every project has at least 2 programmers working on it, you and you from 6 months from now. When you won't remember how or why you did what you have done, object-oriented programming will make your code more readable and difficult to break for your own sake, as well as for any other programmer who might work on your project. There are 4 main principles of object-oriented programming, which are commonly referred to as pillars of OOP: abstraction, encapsulation, inheritance, and polymorphosis, or something. To successfully use the object-oriented programming pattern, you need to only learn and apply these 4 principles. We'll learn about each one of these pillars in detail later on, but for now, let's review them at high level. Oh, great. So is that just something I can do in scripting? Character is clicked. Oh no, I see them have giant... They have giant strings of explanations on these. In case I want to copy and paste stuff. I guess they do that on purpose. But it doesn't say anything about an object or anything. I wonder if they just mean separating it with a bunch of comments is considered the object. Abstraction is the process of removing complex code from scripts or other programs. Programmers will see it and only exposing the functionality of other programmers really need. When you abstract out the details, you reduce duplicate code and provide easy access to most useful methods. The goal of abstraction is to keep your code as clean as possible and simple for other programmers or yourself to use. In our rabbit example above, the hop method would be a good example of abstraction. Without the hop method, if a programmer wanted the rabbit to move, they would have to write code that would access its rigid body and set its velocity, hop height, and so on. With the hop method, all of those aspects are abstracted away, allowing the programmer to focus on when the rabbit should hop rather than how. Oh, so they just mean... Wouldn't that just mean that I'm defining things like I've already been doing the whole entire thing? Inheritance is the process of creating a primary class from which other classes, referred to as child classes, can be created. A child class takes on all of the features of the primary class or parent automatically. This reduces the need to rewrite code that both classes would need to make use of. As an example, let's say that we wanted to create a new class called Bunny. Like Rabbit class, it has ears that can be floppy or standing, has fur that can be a specific color, and can hop. Without inheritance, you'd essentially have to copy all of the code you already wrote and paste it into a new class. With inheritance, you simply extend the Rabbit's class, and that functionality is already there and accessible for the Bunny class. The Bunny class could then go on to feature Bunny-specific functionality, such as eating bunny chow. These examples are interesting. Polymorphism, I think is how you say that. is one of the most useful aspects of using inheritance. It allows you to create alternative functionality for code that's been inherited from a parent class. As an example, our child bunny class represents a domesticated rabbit. It's able to hop just as a rabbit is able to, but a bunny should probably be a little bit slower than its wild parent counterpart. With polymorphism, you can override the contents of the hop method and write custom code that's unique to the bunny. The method call remains the same, but the correct code will be called based on which entity it was called on. Encapsulation is similar to abstraction in that its overarching purpose is to separate the programmer from code complexity. But the focus here is more on code safety in the form of accessibility. Encapsulation gives you tools to code for other programmers and make sure that they can only use your variables and methods as intended. In encapsulated code, other programmers can't easily change the values of variables or properties of objects as impossible to account for all the different ways that other scripts might access your code. So it's far better to encapsulate what you've created so it can only perform as intended. As an example, let's say our rabbit ear type affects its hearing ability. Once that value is set, it shouldn't be changed later on. To ensure that value is protected, you would set it as private, preventing any other outside scripts from accessing it. That sounds like all the stuff that we've already learned, so it's kind of weird that they'd go over this now. Object-oriented programming and missions. If you feel as if some of this is sounding familiar to you, you're right. You've actually already been implementing some OOP principles into your code throughout this pathway. Yeah, well, I guess I'm glad they acknowledged that. As you work through the rest of this mission, try to think about what pillar you might be applying as you write new functionality for your project. In the next mission, we'll visit each pillar in depth as you look for ways to iterate and improve on your code. Pointing out that object-oriented programming isn't only programming paradigm out there. There are many different approaches for creating applications, and ONs are good. You won't use the object-oriented approach for everything you make in Unity. Object-oriented programming, and in fact all programming patterns, are just tools in your tool belt. And while some may be more effective at some things than others, there's one true superior paradigm. Always remember to select the tool that makes the most sense for the challenge you're facing. That said, object-oriented programming is well established and a great tool for new programmers. As you move forward through these next missions, you'll expand your knowledge on these core concepts. In the next tutorial, it's time to get started with the project. You'll implement the scene flow and configure buttons so that the user can move between the two scenes and exit the application. Okay. I've been reading a lot. Ugh. Okay. In this tutorial, set up the scene flow between the menu and main scenes and the exit flow for the application By the end of this tutorial, you'll be able to call the appropriate startup methods in the initialization sequence of the app. Load the scene when triggered by an event. Overview. Allergies. Take a breath. As you reviewed in the previous tutorial, the application you'll be working on in this mission has a number of different scenes that the user needs to navigate between. It has two, or at least I can see two. Right now, the application starts directly in the main scene. In a real-world application, there would be a menu at the start of the application where the user could adjust settings or quit. In this tutorial, you'll create that menu. Review the required scene flow. We've prepared a basic UI menu, canvas, and the main scene, but it doesn't work out of the box. If you need to refresh your memory, take a moment to review the full scene flow overview. Let's begin by setting up your application so that the user can launch the main screen. Exit the application. Okay, and the scene control bar, set the scene view to 2D mode. I haven't had to do that in a while. Okay. We got start, we got exit, we got save, load color. In the hierarchy, expand the canvas, and then container game object, which contains 2 more game objects. Start container and exit. Okay, let's look at those. Canvas, container, start and exit. Expand the start container. Expand it. Start container contains 4 button game objects grouped together in the start container section of the canvas. Start button, a mystery white rectangle, color picker, save color, button, save, load color button, load. The menu isn't functional yet, but you can still review the color selection buttons in action. Let's try that now. In the toolbar, select play to enter the play mode. You'll notice that there are now 4 color selection buttons available in the white rectangle. Exit play mode. Okay. The color selection buttons are controlled by the menu UI handler. Script on the canvas game object. This is a custom script that's been written for this project. Right now, all it's doing is initializing the color buttons. Let's add 2 methods. One to start the main scene, and one to exit the application. Write a method to load the main scene. Let's start by writing a method to load the main scene from the menu. In the project window, go to Asset Scripts, double-click Main UI Handler CS to open the script in your default IDE. Okay, let's give it a look. I'll pop it up on my big thing in a second. Just have to load the visual script. Don't recover. This always takes so long. It'll get there. Just gotta wait for it. It'll get there. Eventually. But what, are we just gonna load the scene? Because we already know how to load the scene and connect it to a button. It's not that hard. Yeah, it just says load scene right there. So I'm guessing that's what we'll do. Okay, that should be loaded up now. Let me just get it on my document. Don't need that there. Okay, there we go. Got all that there. Yeah. Under the start method, add the following new method called start new. Okay. Wrong one. Wrong one. There we go. Why is it not doing it? Was I missing something? Didn't they change the name to something else? Isn't that the problem? Oh. Oh. Okay. That was why. I was right. We were missing something. Okay, so I was right about that. Add the following namespace to the list, the script, and then save your work. Okay, I did that. Let me use in the script file. Okay. Set the main scene index. Now let's prepare to set up a start button by setting the menu scene index. Before you return to the editor, take a moment to review the instructions that you wrote in your new method. Load the scene, scene manager load scene 1. Load scene parameter is a number, but what does this refer to? It's the index of the scene that you want to load. You can define a scene's index in the build setting window. Where the heck is the build setting? It shows it down here, but I don't... Oh. There it is. File build settings. Okay. Does that pop up on this? No, it doesn't. Well, it doesn't say anything that important. It's just 0 and 1. where to set up the start button by setting the menu scene index. Do I need to change that though? The menu is 0, the main is 1. That should be fine. Oh yeah, where's the scenes and build thing? Yeah, that's both right. We didn't have to even do that. Configure the start button. Now you're ready to set up the start button. In the hierarchy, select the start button game object, which is the child of the start container. In the inspector, find the button component on the click on property. This is where you can set the events that Unity will invoke when the user selects the button. Select add to add a new event to the array. That's the start button, Snake. Isn't that what I would want to do? In the function drop down, oh, okay, I see. Oh, so you can just apply those to that, and then the rest of them can do everything. Okay. That's interesting. I mean, it makes sense. Oh, I didn't save. That's why I'm not seeing it. Dummy. I'm like, huh, it's not showing up for some reason. Inconsistent line endings. Script. Just because it wasn't moved over a little bit? Is that really it? No, it still has an issue. Well, we'll ignore that issue for now. Okay, let's just make sure if this even works then. Okay, well it works. Write a method to quit the application. Now let's set up the exit button in the menu screen. Return the handler. Start a new method. Void exit. Okay. I know I didn't show that, but just making sure this is all written up first. Oh, that's what they mean by object, I'm pretty sure. Oh, okay. Okay, the instructions call the method to close an application. Application quit, save and return the Unity under. Press the exit button. Oh, it already grabs it. Okay, interesting. I wonder why it already grabs it. What's how can you change the code to run different lines depending on where the application is running? That's where conditional compiling comes in. You can use conditional compiling to branch code base where the code is compiled in the editor or for a build. Revise your method with conditional compiling. Turn the main menu. Okay, update your exit method with the following. Okay. Does it need the hashtag then? Is the hashtag the conditional? If unit or editor. Application. Else. And if. Why does it not work? Oh. There we go. Just didn't have that on it. Okay. Save your changes. Review the additional code. What does the code mean? All lines starting with hashtag aren't really code. They won't be compiled and executed. They're actually instructions for the compiler. It is similar to code you've encountered before, though. Let's translate it into something a little more familiar. Because this if statement is an instruction, compiler, the part that is not true, will be compiled in your case when the code is compiled inside the Unity editor. It's true, it will keep the editor application playMode code discarded. The application. When you build a player, the Unity editor will be false, so it will keep the application quit and discard editor application playMode. So the hashtag is telling the code itself not to use it instead of just if this or that. It's just getting rid of the code completely. Okay. That's interesting. Well, let's just try it really quick. We can hit the start button. That still works. And if we hit the exit button, it exits play mode. Okay. Add a new namespace. In your return, Unity editor, you may find a familiar error in the console, the name editor. Okay, yeah. I don't know why they don't just say that first. Set up the transition. Set up the transition back to the menu screen. Now users can get to the main scene and exit the application from the starting menu. But the moment they can't get back to the menu from the menu scene, we've created a back to menu button in the main scene, but you'll need to get it working yourself. Remember, you can find the game object for the button in the canvas. Canvas game object has the UI main menu scene script component attached. This handles the UI. In the main scene, you can review the process followed and configure start button if you get stuck. Test your changes in play mode to make sure they work properly. Okay. So, load up this one again really quick. Canvas. It's using the UI main scene. So I'll pull up UI main scene. Ah. Yawn. Okay. This one's pretty simple. I mean, making buttons isn't that hard. I guess you'd set active true, but you need to pause the game too. Well, I wonder if you can make translucent scenes. Well, I won't worry about that right now. Anyways, let us look at the script. Oh, I guess this has an update. Anyway. You get awake. That's set new info. Blah blah blah. Got some public voids, etc. Let me see what we got here. Okay. UI main scene. Can I just call this function? Oops. Do something wrong there? This is a button, right? Oh. Oh, wait. No, that should be fine. Oh, wait, I think I understand. I think I understand now. Oh, okay. I think that will work then. I can't have it that. Yeah, I realized what I was doing wrong. I was, over here. I was trying to put the script down here, but you need to define the thing in your hierarchy so it can use everything. I guess. That makes sense, right? That makes enough sense. But now I have menu open here. We can do that. Save it. Now we got that. A little weird, but we can do that now. Now users can get to the main scene and exit the application starting with a mod. Okay. We did all that. Now you connected your scenes to the UI to meet the mission brief, but there's something missing. The color selection buttons still don't work. In the next tutorial, you'll add this functionality by implementing data persistence. Make it your own. If our pre-centered menu is a little boring for your taste, don't despair. You can customize the appearance of the default menu, or create your own from scratch. This is a great opportunity to consolidate your work. Great with code user interface is important if you do create your own menu. Make sure that your menu buttons include the same buttons that we've used, otherwise the user won't be able to complete the required interactions in the application. They're saying don't change it too much or else we'll make it harder on you. At least all this stuff for this mission seems pretty easy so far. I've been getting through it pretty quick. It's only been like an hour and 30 minutes and I'm almost done with it. But usually then they'll have like a test thing. Though this thing I think had 2 missions in it, so I don't know if it's just going to be this mission and then a test. And then we might be done with the programming section, because I don't think they had anything else. It was just the 3 main ones, right? There might be more. I don't always pay attention to that. Anyway. Ooh, we got video stuff, but I think this is a good moment to go to the bathroom really quick. And we will look at that in a moment. So I will be right back. Alrighty. Oh. Take more breaths. I actually didn't pay attention. Does this GitHub stuff change that too? Modified. Modified. Okay. Okay. Interesting. Now you've set up some of the buttons in the app so that the user can move between the menu and the main scenes, exit the application, or end play mode in the editor. Now let's configure the application so that when the user selects a color using a custom color picker, that the color is applied to the forklift in the warehouse when they launch the scene. Here's what that might look like in your project. To do this, you first need to understand the basics of data persistence. Okay. Data persistence means making data last longer than the process used to create that data. Some examples of data persistence are a specific player icon you select in a one-off multiplayer game, for example, a quiz party game. Your name input at the start of an application and then displayed throughout the session, for example, in a polling tool. Your progress in ongoing long-form games, for example, an RPG game or console. Your work in word processing application. Data persistence between scenes. In Unity, data created within a scene is easily available within that scene. But when a user moves to another scene, what happens? Typically, this data is lost. Data persistence between scenes is the process of transferring data from scene to scene to give the user a consistent experience as they progress through your application. And the first two examples above are examples of data persistence between scenes. They're typically one-session experiences that use multiple scenes. Okay, open new scene. Data goes over there. Data persistence between sessions. Open close app. Data is still over there. The other two examples, ongoing games and word processing applications, are typical multi-session experiences. Users want to save the progress they make during one session, then restore it to pick up where they left off. These are examples of data persistence between sessions. So that's like making a save file. You'll frequently encounter both types of data persistence in more complex applications, data that needs to follow the user as they move between scenes, and that also needs to be saved and restored over multiple sessions. Review your brief. Your brief for the resource management simulation project includes making it possible to select colors in the initial menu scene, and apply them to the forklifts in the warehouse main scene. At the moment, the buttons exist because we provided a custom script for this. You've reviewed these when you set up the other buttons in the previous tutorial. Now let's implement data persistence between scenes by making the select color data available in the main scene. To achieve this, you will use don't destroy on load, a method in Unity that makes a game object to be saved in memory even when loading or unloading a new scene. Static classes are class members. Static class Members can be accessed from anywhere without having to reference a specific object. You may already have used some of these, such as time delta or vector forward. These aren't specific time objects or specific vector 3. The format for static class members is class name, member name. Let's get started. Okay. What am I doing? I can just copy and paste this directly. I didn't even think about that. I can just copy and paste from this if they have that stuff there. Okay. Create a new script. First, you need to create a new script to be the static class where you'll store the data you want to persist between scenes. In the project window, go to Assets, Scripts. In the main menu, create a new script called Main Manager. In the hierarchy, create a new empty game object and name it Main Manager. Assign your new script to the game object and then open the script in your chosen IDE. Okay, open that. Yeah, sure. Make sure that's fine. I don't know what its problem is with my line endings, but whatever. Delete the default start and update methods, and on the following codes, create a static member, the main manager class. Public static. Right, yeah, right there. Okay. Instant equals this. Don't destroy on load. Oh. Okay. This code enables you to access the main manager object from any other script. Is it because it's a public static? And we're saying that the instance of the static is awake, and then it is don't destroy it. Let's go through the code line by line. Class member declaration. This is the static class member declaration. Note the keyword static after the keyword public. This keyword means that the values stored in the class member will be shared by all the instances of that class. It seems like something I should probably have written down. For example, if there were 10 instances of main manager in your scene, they would all share the same value stored in the instance. If any of those 10 main managers changed value in it, it would also be changed for the other 9. Awake method code. Next, you added code to the awake method, which is called as soon as the object is created. This don't destroy object. The first line of code stores this. In the class member instance, the current instance of the main manager, you can call main manager instance from any other script, for example, the unit script, and get a link to that specific instance of it. You don't need to have a reference to it like you do when you assign game objects to script properties in the inspector. Marks the game object attached to this script not to be destroyed. Scene changes. Okay. Test in Unity Editor. Let's test those changes in the Unity Editor. Return to the Unity Editor, open the main menu scene, and enter the play mode. Check the game objects in the hierarchy. The main menu has been moved from your normal scene to a special scene called Don't Destroy on Load. Note the scene also has a new game object called Debug Updater. This is a debug game object used by Unity. You can ignore it. Select Start to launch main scene. The main manager game object is still there. Success. To return, there are 2 main manager objects. This happens because the main manager traveled with us. Let's fix it next. Okay. Modify the awake. Update the awake method with the following code. Start of new code. If instance null. Destroy game object. Turn. Oh wait, no, I don't need that there. Okay. Oh, I need that. Save your changes, return the Unity error, find out what happens. Review the new code. You just added conditional statement to check whether or not the instance is null the very first time that you launch the main scene. No main manager will have filed the instance variable. This means it will be null. So the condition will not be met and the script will continue as you previously wrote it. However, if you load the main scene again later, there will already be one main manager in existence, so the instance will not be null. In this case, the condition is met. The extra main manager is destroyed and the script exits there. This pattern is called singleton. You use it to ensure that only a single instance of the main manager can ever exist, so it acts as a central point of access. Huh. Just wanted to make a note of that. Oh, store and pass selected color. Okay, now we gotta get into the nitty-gritty. Return to the main manager in your IDE, add a public class member called Team Color above the awake method. Added more. I don't know why it capitalizes these when it tells us not to all the other times. Okay. Did that. Save your changes and return to the Unity editor. Open the main handler script in your IDE. In the script there is a method called new color selected, which is called when the user picks a new color. Let's retrieve the color and store it in main manager. Okay. New color selected. Main manager instance. Team color. Cool. Color. Okay, that's it. The color that the user selects is now stored in the main manager, so you can access the team color variable from the main scene to retrieve it. Now you just need to apply it to the forklift in the warehouse, save your changes, and then return the Unity editor, open the unit CS script in your IDE. Okay, so it can store the color, but it doesn't know where it's applying the color. They want me to grab the units. Add a new start method with the following code. Not null. You'll set the color. Save your changes to review the new code. Set color is a method we've written for you to set a color to the unit, the forklift. Note that it checks whether main manager instance is null before setting the color. Main manager will be there as it is created in the initial main menu screen. So why do we need that? Well, if you want to test quickly, then you may want to start the main scene in the editor directly without passing the menu screen. In that case, the main manager won't exist and the main manager instance will be null. This code prevents an error in case the programming runs the main scene by itself without passing by the main menu screen, making it easier to test things quickly. Try testing again the union error, select, see what happens. Okay. Okay, but I'm having a problem here. Oh. Wait. No, I have that right. Public team color. That's public also. That's public. That's private. Oh. Did I just not save it? I guess I just didn't save it. Okay, so if we go over here, we should see main manager be loaded. And then if we go to the main menu, we should only see one of these. And we can click that. Start. Okay, it's not working. It's supposed to work. Set a color to the unit. As the unit CS. Add a new start method, following code. No. Equal set color, main manager. Instance team color. Set color is a method. Now that it checks whether the main. No. Okay. Nothing happens. Object reference not set to. What's the problem here? Oh, wait. That was the problem. I didn't capitalize the S and start. Okay, well, let's try it now. So right now they're all black, which makes sense. That's the default color. Okay, now they're actually different. Huh. Okay, I guess it's fine now. Weird, it wasn't working for a second. Huh. Let me just show that in the actual example. Click color, changes color. Click back, click new color, changes back. Click back, new color, changes. Click back, exit, and closes it. So it does what it is supposed to do. Now you achieve the first part of implementing data persistence in the application, data persistence between scenes. In the next tutorial, you'll expand this further by implementing data persistence between sessions of the application. So when the application goes off, how do you keep things alive? That would be interesting to see. Ugh. Almost at the checkpoint. Oh, okay, let's see. Right now, when you're testing the work in progress application, the color that you select for the forklifts in the warehouse won't be saved the next time you test the application. If you create a build of this app It will be a standalone experience each time the user runs it. It would be helpful to save the user's last chosen color, so that's automatically selected when they start the application. In this tutorial, you'll build on your previous work to implement data persistence between scenes and do so between sessions. Here's what that might look like in your project. Okay, evaluate your brief. In this tutorial, you're going to write the color selected by the user to a file. Then you're going to configure the main manager to check whether that file exists when the application starts. If the file does exist, then the main manager will read the color stored to it and set the color picker to that color. Before you get started, take a few minutes to review project brief. Imagine that you will perform this task on your own. Write down answers to the following questions. What do you need to implement, and where will you implement it? Write down your thoughts. Now compare them with the approach we take. Where have you encountered similar functionality before? And create with code or learning experiences, even if you can't access code. Think about examples of data persistence between sessions that you're familiar with. Beyond Unity Learn, what resources can help you do this? Think about options within Unity ecosystem and beyond it. Take a few minutes to reflect on what you already know before you begin this task. Is a very useful exercise, particularly if that task feels challenging. If you completed Unity Essentials, you explored the mindset established creators to take to learn Unity. This is a great time to refresh your memory on that approach. Okay. Kinda blah blah blah. Anyway, for data to persist between sessions, it needs to be stored in some way. In your case, you'll need to convert the color of your user selects into a format that can be stored and then read when they load the application again. The process of converting complex data into a format in which it can be stored is called serialization. When you're ready to access the data again, the process of converting it back is called deserialization. Ooh, JSON. Haven't seen that in a hot minute. Java files. There are different formats that you can use to store data depending on what the data is and what you want to do with it. In this case, you're going to use the JSON format. JSON. A text format used to store data and exchange it between platforms. It was first developed for the web. Its full name is JavaScript Object Notion. It's based on JavaScript, but is language dependent. You can use it whether you're writing C# code or using any other programming language. The JSON format stores data in the format of key-value pair. The key is a string, and the value can be a number, string, boolean, an array of values, another JSON object. How does this format work? The following JSON string encodes the object storing basic information about a person. Okay, let's break down the example. Each object is surrounded by curly brackets. Each entry is in the form of a key value pair, separated by a comma. So the key's name, then colon, then you input the value, or the pair of values. The entry pet is an array of strings. Array values are listed between square brackets. The value associated with the entry addressed is between curly braces too. This is because it is another JSON object. Okay. JSON was developed to exchange data between different systems, which makes it a good fit for saving data in your application. Unity has a helper class called JSON utility, which allows you to take serialization, a serializable class, and transform it into its JSON representation. Let's see how this works for both serializing and serializing data, considering the following player data class. Imagine that you want to pass this class to JSON utility with the following values. Calling string JSON equal JSON utility dot to JSON my data will represent the following or result in the following string. Note that since position is a vector 3, it is encoded as a JSON object with 3 different keys, x, y, and z. This is because vector 3 class, extremely simplified, is, deserializing data. JSON utility also has a method that does the inverse of the process you've seen from JSON T. This method will take the string containing some data and create an instance of an object with its fields filled in. Using the template argument, as you may have noticed when reviewing the player data JSON string. The original type of that data is not stored in the JSON file. Utility needs the template argument to read the right value in the right field. To extend our example, calling player data, my data equal JSON utility dot from JSON, player data JSON will fill my data with values in the JSON string. Limitations of JSON utility. There are some limitations to utilities. JSON utility class, which is designed for performance and simplicity. JSON doesn't work on primitive types, arrays, lists, or dictionaries. As you might expect, JSON utility only works on serializable type monobehavior, or the other classes structures you write onto which can add the serialized attribute. If you try to save a class that contains multiple pieces of data, and one of them won't save, it's probably because it isn't serializable. For example, if you convert a class to JSON that has a dictionary in the middle, the dictionary won't be saved because it's not serializable. If something appears not to be saving properly in a class, check to make sure that it's serializable type. Trouble issues with saving data. As you might expect, JSON utility only works on serializable type, monobehavior, and the class structures you write, which you can add serializable attribute. If you try to save a class that contains multiple pieces of data, and one of them won't save, it's probably because it isn't serializable. For example, imagine you have converted JSON to a class that has lots of data in dictionary middle. Why is it? It just repeated the same thing. That's weird. I wonder if that was a mistake. Add a save data class. To save and load users' last chosen color, you'll need 3 things in the main manager class. A save data class that stores the color, a save method that transforms that class into a JSON format and writes it into a file, a load method that transforms the data from the JSON file back into save data class. That makes sense? Let's start with the save data class. Open the main manager CS in your IDE. Okay. Bring that back up. Add the following code at the end of the main manager class within the scope of its closing brace. Within the scope of its closing brace. Serializable. Or do they mean I want this down here? I do want it inside of it still. I don't know. Review the new code. Saved as a simple class, which only contains color the user selects. Note that you have selected a serialized attribute above it. Line is required for JSON utility. As you just learned, it will only transform things to JSON if they are tagged with serializable. Are you creating class and not giving main manager instance directly to the JSON utility? But most of the time you won't save everything inside of your classes. It's good practice and more efficient to use small classes, to use a small class that only contains the specific data that you want to save. I think within the scope of its closing brace means that it's still together. Think that means that it just has to be above this. Think. Not sure. I guess we'll figure that out in a bit. Leave a line free after save data class. Add the following code. Save data. Data. Equal new save data. Data team color. Team color. String. JSON utility. JSON. Data. Oh. And then file, write all text. Application. Persistent data path plus save file on JSON. Oops. Oops. Using system IO. Okay. The final line will be highlighted as an error in your IDE because we need to add the following new namespace, the script at the top, your script add the following, review the code, that stuff. Let's break down the new method in sequence. First, you created a new instance of the save data and file its team color class member with the team color variable in the main manager. Save data equal new save data team color. Next, you transformed. Excuse me. Next, you transform the instance to a JSON with JSON utility to JSON. Finally, you used a special method, file write all text, to write a string file. The first parameter is the path to the file. You've used a Unity method called application persistent data path that will give you a folder where you can save data that will survive between application reinstall or update and append it to the file name save data. Note Unity scripting API lists actual paths per platform. The second parameter is the text you want to write in that file, in this case, your JSON. Add a load color method. Now let's add the load color method. Leave a line free after save color method. Add the following code. Time to load up that color. Okay. So we want string path equal application persistent data path say file.json. Then we want if file, it just exists. That's kind of funny. Exists path. So we're saying show us the path if the file exists. I'm guessing that's what that means. File. And then you read all of the text, so then it knows what color you're getting. Read all the text in that file path that we're defining. And then that becomes save data. Or it becomes the new data. Something like that. From JSON. And then team color. Equals data. Team color. Ugh. So it's going to try to find the string, say file JSON. And it's going to find it under the, I'm guessing this means it would find it under, like, you're defining the path for it to find this file in. So I'm guessing you're telling it to find it under the application's files and look for the file under the application data that's called save file, and then If that exists, you follow this new path to make it read everything that is in that document. And then that would mean that the save data is now this new stuff. So we'll go back up to here, and then it'll read the save data for whatever color it has, I think is the basic idea. The method is a reversal of the save color method. It uses the method file exists to check if a JSON file exists. If it doesn't, then nothing has been saved, so no further action is needed. If the file does exist, then the method will read its content with file read all. It will then give the resulting text to JSON utility from JSON to transform it back into a save data instance. Oh, okay, so it transforms it into save data, and then you're telling it that's the save data equals new data. Finally, it will set team color to the color saved in that save data. Double check your new code. Or you continue double check the code you've added to make sure it's within the scope of the main manager class. Okay. I think that's correct. Load and save the app. Save the color in the application. You're nearly finished, but first you need to load the saved color, if one exists. When the application starts and saves the color on exit, let's implement that now in the main manager, which you still should have open. Find the awake method, call the load color method at the end of awake. Okay. Save your changes, then open main menu handler. Then open menu UI handler. Okay. I'll open that. At the end of your start method, add the following code: color picker, select color, main manager instance team color. Picker, select color, main manager, instance, team color. Okay. The line will pre-select the save color in the main manager if there is one. When the main menu screen is launched at the beginning of the exit method, add the following code: main manager instance save color. Okay. This line will save the user's last selected color when the application exits. Add testing functionality. Finally, let's add some quick testing functionality to the main menu UI handler so that you can save and load the color from the application instantly. Add the following two methods to the menu UI handler: save color clicked, load color clicked. Okay. Then we want public void. What was it? Load color click. That's fine. Oh. I'm dumb. Load color. Got that. Load color picker. Flex color. Oh, okay. A lot of coding. Save your changes. Link these methods to the load and save color buttons. If you need to recap this process, review. Configure start button. Test in the editor. Looks like they're already linked to it. Yeah. They're already linked to it. In this tutorial, implemented. Okay, we didn't even test if those worked though. But okay. So we can unlock a bedroom from this. Is a free little asset. Got a kitchen, got a bathroom, got a bedroom. Do we have a bathroom? I think they gave us a bathroom. I think it was kitchen, bathroom, and bedroom now. So we have in theory, we have a house that I could scrunge up into my own little horror house. Okay, so now we have a quiz. Let me just really quick see if this even did anything. Looks like it did. Maybe it didn't. Maybe it didn't. Which of the following is considered a version control solution? Well, actually, just real quick. I guess you can already see it though, right? It doesn't matter much. Which of the following is considered a version control solution? Well, we're using GitHub, so I'll assume GitHub. Let me just make sure I saved all of these scripts really quick too. Okay. Which of the following is not typically done by a version control solution? And revert back to previous. Is that true? They want you to get 8 correct. Which of the following merge conflict arise? When would a merge conflict arise? When two computers push the exact same file, the exact same code at the exact same time. When changes are made to the same line, the same file on different branches. I mean, I guess. That sounds like a more extreme issue. Why can't they just give the... Because this wouldn't cause it. It would only cause that if they're different. But that doesn't say it's different. That's why I hate those questions, but then it's probably going to be that one, because they're just like, you should have assumed that that's what we meant. What does it mean to check out a branch within a version control solution? Updates your working directory. E to manage version, stored in branch, remove a branch. I don't know. This one? Sure. Which of the following would represent a typical workflow for the version control solution? I don't know, this one. In Unity scripting reference, the following is shown for the load scene function. Scene manager, load scene. Which of the following would be a valid implementation of a load scene method? You can build into... I guess it would have to be one or two, well, 2 or 3. But neither of those are an index. I don't know. I'll just say this one. If we get them wrong, we'll just retake it again anyway, right? This doesn't have a wicked long wait time. Yeah, we can just take it again right away. Who cares? When you want to use the don't destroy load function, when you don't want a particular game object to destroy other game object, when you want an object to ignore all destroy calls, you want to save information about a particular game object and count between scenes. Tended to reload the scene every 3 seconds, then display the number of times it has reloaded in the console with a reload number 0, then reload number 1, reload number 2, etc. every time it is reloaded. The increased reload number variable is not being retained when the scene is reloaded, so it prints reload number 0 every time. What change would need to be made in order to make the program work as desired? We'd want it as static, right? Yeah, because it's public. We want it static, because it's not supposed to change unless that happens, right? Well, as an example of singleton design pattern implemented game manager, which of the following is true about this class? Hmm. This one is weird. Why does it have get private set? The get private set thing is the thing I don't understand. I don't know. Tell me we get wrong. I kind of figured I'd get around 6. Oh, I got that one right. The ones I got wrong was the option that meets the parameter criteria. Integer lead scene mode. That's what you think. That didn't explain anything. Gives you view access through range. It sounds the exact same. Hmm. Really? 7 that time? No, brother. I'm gonna have to start doing the copy everything in a second here. Actually, wait, I didn't pay attention if I got that one right. Wait, didn't I still get this one wrong? I don't know. There, that one was good enough. What one did I get wrong that time? The merge conflicts thing still? There we go. Whatever. Whatever. This is dumb. Featured submissions. Brick Breakers, Data Persistence, Junior Programmer. Great example. This mission has been updated. Just in case we refreshed this mission while you weren't working, please be sure you completed this content before attempting this submission. Okay. In the previous tutorials, you've implemented data persistence both between scenes and between sessions in an example project. In the submission challenge, you will apply both of those techniques in a new game project. You'll save the user's name between scenes and save their highest score between sessions. Best score too. To help you focus on your data persistence skills, we have provided you with a simple breakout style game that is functional but has no data persistence implemented. Even so, you are welcome encouraged to create your own simple game from scratch instead. It just needs to be able to display the user score. In this submission, you'll create a new repo, do an initial commit, import a project version, and version control and commit it, implement data persistence between scene sessions. Okay. So, what I could do is add on to the game that I already made. is what I'm thinking. Instead of doing what they're doing, I could add on to my little ball game. But give me a moment. I'll be right back. I'm just gonna break again, refill my water and all that. Alright. So, I was just thinking I should probably save some of my references in here for the main manager. Okay. I just wanted to make sure I saved that. Anyway, create a new repo. To make sure your project is back up and ready for version control, create a new repo. For it, this will allow you to share code more easily with your fellow learners later on. Create a new repo for your project to do GitHub desktop, making sure select Unity for the GitHub dropdown, etc. Do all that good stuff. Open the project and do an initial commit. Okay, implement data persistence. You're now ready to begin the challenge of implementing data persistence. The key feature you need to achieve are saving data between scenes. A piece of data set in one scene will be stored and used in another scene. Saving data between sessions. A piece of data set during runtime will be saved and used the next time the application is run. Although there are many ways you could implement these features in an application, here is how we suggest you implement them in this particular challenge. Player name, saving data between scenes. Create a new start menu scene for the game with a text entry field prompting the user to enter their name and a start button. When the user clicks the start button, the main game scene will be loaded and their name will be displayed next to the score. High score, saving data between sessions. As the user plays, the current high score will be displayed on screen alongside the player name who created the score. If the highest score is beaten, the new score, the player name, will be displayed instead. The highest score will be saved between sessions so that if the player chooses and reopens the application, the highest score player name will be retained. Feeling ambitious, you could add additional data persistence features as well. For example, create a separate high score scene that displays the high score, display multiple high scores instead of just one, create a setting scene that allows users to configure gameplay and use that information between sessions. Submit your project. Okay. Okay, well, I think we can do something interesting here. Though this might take a while. But we'll see. We'll see how long it takes. Is there anything else in here I would need to save? I pretty much just need to remember to use null. I should save this. Okay. So, I can do the block thing if I need to, but for right now, we'll close out of this. Close out of that. I'll open up my ball game. I figure someone was already asking me to do this sort of thing anyway, so I might as well. I could try and make a pause screen that just has the high scores listed. That could be easier. Or it could be a lot harder. But in my mind, it would seem easier. Ugh. Bien. Okay, ball game loaded back in. I'll just preemptively start loading up the scripting stuff. Should I move all of my menu stuff to a different scene? Make sure this is on the correct one. There we go. So, we have our little ball game. Got our box. We got our ability to score points. We got our player trapped inside of their cube, as they are Capsule Man. But when we load, we got our little game going. Down, 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 down. But then it starts. No. So that is what we have. And it doesn't let us start till we hit the play button or whatever. Menu. But I can't take all of this stuff and put it over there, right? Like, I can't just do that. Go over here and paste it, right? Oh, I guess I can. Never mind. It keeps all of the scripts also. Hmm. Here. Let me see. This is just the title screen. That's not doing anything. The play button is what's doing things. We have the play button script connected to it. I'm just curious if this breaks if I hit play on this new scene. Keeping track of all of them. So I would want a game manager to persist between both scenes. So, let's see. We want the game manager to persist between both scenes. The simplest thing to do would be this. We want to make a static. And wait, and they find this written. Oh, public static, yeah. Oh. Okay, does that not conflict with anything? Hmm. Oh yeah. Yeah, that's fine. Okay, well the game manager won't be destroyed when switching scenes. Hmm. Gosh, probably actually do this. Oh yeah. Wait, how did I do this last time? Uh, sure. Does that make the repository or no? Oh, there we go. Let's have fun time. What do I want to say?
Okay. Uh, let's get all this stuff up. Oh. I guess because I did more to this one, it's going to take longer. Hmm. Game manager, play button, get component. Hmm. Hmm. Thinking how we want to do this. Hmm. Let's see. Hmm. don't think I used that anywhere else. Probably change the name of it. Instead of set difficulty, I should change it to say that it's something else.
This thing is taking a while to update everything. And it's killing my bit rate. Hmm. Hmm.
Let's see. Can't really do a lot until this is done loading. Why repositories take so long? Probably because I did everything for this project already. That's always funny. I need this. By the way, I'm specifically this. Wait, what? Well, plan on doing more writing tomorrow. I wanted to get this stuff in a little bit because I hadn't worked on it in a little while there. Already been 3 hours, though it also feels like it hasn't been that long either. I'll have to take out the trash soon. I haven't eaten dinner yet, so I'll need to do that. Taking a while. Getting there. Well, it seems like this is going to take a while, so maybe I'll just stop for now. Seems like a good time to stop. And I've already showed this project before. I might just complete this off stream, maybe. But, the point is, I was thinking about making a separate scene for the menu, and then making either a high score scene, maybe add something to explain what the objective of the game is. Something like that, and, yeah, we'll just get a few other features in there and see if we can somehow track a high score. Which I think I'll make a separate screen for the high score. And if I get all that done, then I can show it the next time I'm doing this. Or keep working on it, depending on how my time is, I suppose. But for now, I do need to eat dinner, need to walk dog. And, yeah. This thing is still loading anyway, so... yeah, it's at 52% right now, just to put that in perspective. It's gonna take a little bit. So, for now, for anyone who dropped in, thank you for watching. Thank you for learning with me, and listening to me rumble and ramble, and fail horribly at the quizzes. Because I don't understand what they're actually saying, regardless if I actually know what they mean. That makes sense if you don't think about it. But I'm gonna go for now, so bye.